Bisection method is one of the basic numerical solutions for finding the root of a polynomial equation. It brackets the interval in which the root of the equation lies and subdivides them into halves in each iteration until it finds the root. Thus, the bisection method is also called the bracketing method. For example, find the root of x cubed minus 2x minus 5. First of all, we need to substitute until we get fx positive and negative value. We substitute x equal to 0 in the equation, so fx will get negative 5. When x equals to 1, then we substitute it in equation, fx will be negative 6. Then we substitute x equal to 2 in the equation, fx will be negative 1. When x equals to 3 and we substitute it in equation, fx will be 16. So we get the interval 2, 3. Because when we substitute s equal to 2, it will get negative value. And when we substitute s equal to 3, it will get a positive value. Basically, in integral, it is a, b. So after we find the interval, we can go to stage 1. But before that, we need to find x1 using the formula. x1 equals to a plus b divided by 2. x1 equals to 2.5. After we get s1, we substitute s1 into the function. So fx will be 5.625. When fx is positive, we replace it in interval b. So our new interval is 2.5. Because when we substitute x equal to 2.5, we will get fx positive value. So we find the new interval. Let's go to stage 2. Same like before, we find x2 using the same formula. x2 equal 2.25, then we substitute x2 in the function, so fx will be 1.890. When fx is positive, we replace it in interval b. So our new interval is 2.25. Repeat it until fx approaching to 0.
After we find the new interval, we can go to the stage 3. But before that, we need to find x3 using the same formula. So x3 equal to 2.125. Then we substitute x3 in the function, so fx equal to 0.3457. fx is a positive value. We replace it in interval b. Because when we substitute 2.125 in the function, fx will be positive. So the new interval is x is 2 and y is 2.125. Then we can go to stage 4. We need to find x4 using the same formula. So x4 equal to 2.0625. Then we substitute x4 in the function fx equal to negative 0.35132. fx is a negative value. We replace it in interval a. Because when we substitute 2.0625 in the function, fx will be the negative. So the new interval is x is 2.0625 and y is 2.125. Then we can go to stage 5. We need to find x5 using the same formula. So x5 equal to 2.10. Then we substitute x5 in the function, so fx equal to 0.166. Fx is a positive value. We replace it in interval b. So the new interval is x is 2.0625 and y is 2.10. Then we go to stage 6. We need to find x6 using the same formula. So x6 equal to 2.08125. Then we substitute x6 in the function. So fx is equal to negative 0.147. Fx is a negative value. We replace it in interval a. So the new interval is x is 2.08125 and y is 2.10. To find the root for this equation is by using the same formula. So the root is 2.090625.
The fixed point method is a numerical technique used for finding the root of a given equation. In simple terms, it involves transforming a given equation into an equivalent form where the solution can be obtained by repeatedly updating an initial guess. The method is particularly useful when solving nonlinear equations.
For now, we have to set up this equation into simple fixed method. And for instance, there's a lot of ways that we can change, that we can break this equation. For instance, you can bring the 2x on the other side. Since there's 2x, you can divide the x. You can divide the x by 2, and you get the first iteration. For another one, we can factorize the first two number in the front with x bracket x square minus 2 minus 5 equal to 0, and then we can bring 5 on the other side, and just by that we can divide all in the bracket, and we got the another one. So for the another one that we can do is by bringing all the in front two number on the other side by 2x plus 5. Since the x is cube, you can just cube root on the other side, and you got third iteration.
So now we are going to find the value of x root using all the trial. As you can see, the root of x using calculator is 2.0945. And now let's look trial 1. Trial 1, the x equals to x cubed minus 5 over 2 when x0 equals to 0. And x0, when we use the equation of x, we find out the answer is negative 2.5. And let's see x1. x1, we sub the negative 2.5 into the x, and we find out the answer is negative 10.3125. And x2, we sub the answer of x1 into the x2. The answer is negative 550.56. And as we can see, the answer is invalid. Why? Because it is not converging. So let's see trial 2. Trial 2 is x. We are using x equals to 5 over x squared minus 2 when x0 equals to 1. And first, we sub 1 into the x0, and we find out that the answer is negative 5. And x1, we sub negative 5 into the x1, and we find out the answer is 0.2174. And x2, we sub the answer of x1 into the x2, and we find out the answer is negative 2.5605. and it is invalid. It is because it is not converging and it is an inconsistent number. So now let's look at trial 3. Trial 3, x3 minus 2x minus 5 equals to 0, and x equals to cube root of 2x plus 5 when x0 equals to 0. And we can find out that the answer of x0 is 1.7099, and x1 answer is 2.0343, and the answer of x2 is 2.0854, and the answer of x3 is 2.0931. And as we can see, the answer in trial 3 is valid. Why? Because it is converging to 2.0945, which is the root of x using calculator to measure it. That's all. Thank you.